Hello, my name is Arlie Mosquera, student of Group 1. In this study focus how fluid, height and density impact exit velocity through an orifice. The experiment used bottles with three holes and different heights and tested waters, salt waters and used oil. The theoretical foundation is Bernoulli continuity equation. The Bernoulli equation linking pressure and velocity, and the continuity equation is mass conservation. Higher fluid height converts potential energy into faster flow. In this work, you said the method measuring time and horizontal distance for holes at 5.5, 50, and 22.5 centimeters result aligned with theoretic, though minor discrepancies occurred due to real-world factors like viscosity.
Continuing with the presentation, we have effect of fluid jet on velocity. Here we observe how the height of fluids effect is velocity. According to the principle of energy conversion, fluid stored at higher elevation has more potential energy with 10 into kinetic energy as it flows out. This is why the flow from the haze hole moves faster and travels farther horizontal than fluid from a load's hole. Velocity profile. This slide compresses the velocity of the flow from the different joles. Velocity profile. This slide compresses the velocity of the fluid from three different joules at 5.5 cm. The velocity is the lowest. At 15 cm, the velocity increases, and at 22.5 cm, we see the high velocity range. This supports our previous explanation about the relation between height and the velocity. Impact of flow density on flow behavior. This section explains how the density of the fluids affect the flows water while the density of about 1,000 kilograms per cubic meter behaves normally towards which is slightly denser, has a bit more resistance, so its flow stays slower. Loose oil has a lower density and higher viscosity, which says it flows more slowly, and in the different parent the water.
My name is Kelly Diana Lopez Hidárraga. Comparison of experimental and the theoretical result. Theoretical values. Calculate using Bernoulli equation. Experimental velocities. Measure velocity taking into account the real effects of friction, turbulence, and viscosity. Discrepancies. Difference attributed to fluid viscosity occurs. Engineering implication and application. Design of fluid system. Hydraulic equipment. Environmental studies. Key takeaways and future direction. Height is critical. Density influences flow. Validation of theory. Application growth.
Good afternoon. My name is Oscar David Amaya, a civil engineer student from the School of Military Engineering. Result and analysis. The results showed that for liquids, the lowest hole produce the highest exit velocity. This confirms that a greater liquid height above the hole results in more energy and higher velocity. Is what was also observed that salt water, having a higher density, moved slower than pure water. On the other hand, oil, being less density, showed intermediate velocities, minor difference between theoretical and experimental values were attributed to measurement errors, internal friction, or turbulence in the stream.
Hello everybody, nice to meet you. My name is Wilma Rojas, I'm civil engineering student. Continue with the presentation about Bernoulli principle. We are going to review a box experiment that demonstrated how this works. We are going to explore the discrepancy between theory and practice. Validate the equation using date and reflect on this application is both in both engineering and education. First of all, I'm going to talking about the difference between theoretical and experimental results. Minor mistakes in the method can cause deviation, the internal friction because of viscosity, discrete flow, the flow speed. And turbulence could affect consistency of the experimentally. All these factors contributed to the real world difference from Bernoulli ideas model. So, despite this variation, the experiment supports Bernoulli equation. We are going to observe that like a fluid height is increasing, velocity rose conforming the role of potential energy. Fluids with hinder this stay slower watching theoretical productions. Overall, or find conforming the equations reliability under controlled conditions. Finally, this experiment has shown real-world relevance. Engineers use it to design irrigation systems and hydraulic networks. And in education, this is a simple, low-cost way to help students visually and understand fluid dynamics. Okay, thank you all very much for your attention. Good evening.